Question 4. We just label the equation 1, equation 2. So first thing we need to do is to substitute y equals 2x minus 4, equation 2, into equation 1. Now I've put 2x minus 4 into y. Now I'm going to rearrange and make x to the power 2 the first term. Okay, so what I've done is I've taken minus 4 to the right hand side. I get plus 4. I've taken plus 2x to the right hand side. I got minus 2x. Minus 2x minus 4x is minus 6x. 4 plus 5 is 9. That equals to 0. So what I've done is a equals 1. B is minus 6 from quadratic, and C is 9. So I'm looking for AC because I want to factorize. AC is 1 times 9, which is 9. So I need two numbers that I can multiply together to get 9. And if I add them together, I get B, which is minus 6. So I choose minus 3 and minus 3. So what I need to do now is to put x here and x there. Now I can replace minus 3x minus 3x with minus 6x. Now I can see x squared minus 3x minus 3x, this is minus 6x, plus 9 equal to 0. There's a common factor here, it's x. X is a common factor here, and minus 3 is a common factor here. So I'm taking x out, I get x minus 3, and I take minus 3 out here, I get x minus 3 as well. Because if I expand this back, minus 3 times x is minus 3x, and minus 3 times minus 3 is plus 9. Now I've got x minus 3 as a factor and x minus 3 as a factor. So I've taken x minus 3 as a factor, and what is left is x minus 3. X minus 3, and that equal to 0. So therefore I have x equals to 3 and x equals to 3. That meant the linear touch the quadratic at x equals to 3 only, which is a tangent. Now we need to find y value. We know that y equals 2x minus 4, which equals 2 times 3 minus 4, and that equals 6 minus 4, which equals 2. So y equals 2. Now we can sketch y equals x squared minus 4x plus 5, and y equals 2x minus 4. The point x equals 3 and y equals 2 is the point of the tangent between the linear and the quadratic. The best thing to do first is to find the turning point of the quadratic. At the turning point, x will be equal to minus b over 2a. It is also the point where x is the line of symmetry. So what happened is minus b is minus 4, so I'll put minus 4 there. Minus 4 times minus is 4. 2 times 1, a is 1, and that gives 2. X equals to 2 is the turning point. We now need to find y at the turning point, so I can substitute x equals to 2 into that equation. Okay, so now I've put 2 in there as a function f of 2. That is 2 squared, so 2 squared minus 4 times 2 is minus 8 plus 5, and that gives 4 plus 5 is 9. 9 minus 8 is 1. So now we can mark the turning point on the graph. So when x is 2, y is 1. X is 2, y is 1. So that's the turning point. Plus 5 is the intercept on the y-axis, or when x is 0, that y would be 5. So the intercept is plus 5 on the y-axis. This is the parabola for the quadratic curve. The line of symmetry is when x equals 2. That will be the line of symmetry. So therefore, I'm going to draw the line of symmetry here, x equals 2. The linear curve touches the parabola at x equals 3, y equals 2. X equals 3, y equals 2. To draw a straight line, we need 2 points. We need another point to be able to draw a straight line so we can get the direction of the straight line right. I could say when x is 0, y will be minus 4, or I could say when x is 4, y is 4, because 4 times 2 is 8, 8 minus 4 is 4. Now I got my 2 points to draw a connecting straight line. That is my straight line, and that's the intercept where they cross between the quadratic parabola and the linear straight line. So that's the quadratic parabola, the green one, and the linear straight line, the red one.